Hi everyone, welcome back to my training series entitled Understanding EMV. This is the 22nd video in the series, and in this video we'll be looking at the 10th step of the EMV transaction. As usual, let's do a recap. Excuse me. So we know Bob is buying socks, and we know that he's at the store. Fortunately, he's got an EMV card, and the store has an EMV compliant terminal. So Bob's inserted the card into the terminal, and this means that we've selected EMV as the technology for this transaction. Okay. The next thing that we did was we identified the virtual card, residing on Bob's multi-app card, and we selected it for the transaction. Okay. Which takes us into step 3, at which point we know, that we've got the virtual credit card application in the card, which has been chosen for the transaction. So therefore, it and the terminal are now going to have a conversation, and they are going to exchange some information. The terminal verifies that the card is authentic in step 4 of the transaction. The terminal verifies that the transaction itself is valid. The terminal then verifies that the person attempting to use the card is the genuine cardholder. The terminal does some risk management processing called terminal risk management, which is step 7. We then go into step 8, where the terminal considers all of the conditions and compare. So it considers all the conditions it found in the transaction, and it compares it against a set of rules, to formulate an opinion in terms of how it would like the transaction to end. Okay. It then supplies this to the card in step 9, which is card action analysis, and the card takes the terminal's input, as well as it performs its own card risk management to complete the card action analysis step, where it formulates an end result for the transaction at this point, right? We then go into the next phase, which is the first gen AC phase. And in this phase, the cryptogram, the actual cryptogram is generated by the card, and this, decides how this transaction is going to proceed, right? So there are two possible options here. One is that we could either approve or decline this transaction offline, or so in this case, once we've passed this phase, we would then just go straight into completion and the transaction is over. But the other possibility is that we could decide to send the transaction online. Okay. So let's get straight into the first gen AC step of the EMV transaction. Okay. All right. So firstly, first gen AC refers to the first generate application cryptogram phase of the transaction. Okay. And an application cryptogram tag 9F26 will be generated during the first gen AC phase of the transaction. Okay. And remember the previous video, we said, the card will first look for reason to decline, and if it can't, it'll look for reason to send a transaction online, and if it can't, it'll default to an approval. So in the first gen AC, it will generate the actual cryptogram that will result in a decline, a go online, or an approval. Okay. Several data elements from both the terminal and card will be used to construct the application cryptogram. Okay. These data elements are requested by the card from the terminal during the transaction through the use of a CDOL, right? Card Risk Management Data Object List, or it's easier just to say CDOL 1, and the tag, the EMV tag for CDOL 1 is 8C. The terminal responds with this required data to the card just before the first gen AC is processed. Okay, so what I've got here is a list of tags, and this is the bare minimum. This is mandatory, right? Tags required for generating the cryptogram. Now, some issuers may include additional tags as per their discretion. So instead of having just these, they could choose to add another tag or another 2 or 3 more tags uh, at their own discretion. But currently, these 2, 4, 6, 8, 10 tags are the bare minimum required to generate a cryptogram. Okay, you'll see that 8 of them come from the terminal. So it's the amount of the transaction. It is an amount other than if it was a purchase to cashback transaction, you'd have an amount authorized and the amount other separating the purchase from the cash value. The terminal country code, the TVR, the the currency code of the transaction date and transaction type. And remember the unpredictable number we spoke about, many videos back, which the terminal will generate during every transaction. So all of these items are used to generate the cryptogram, and these are sourced from the terminal. From the card itself, it throws in the application interchange profile, the AIP. Remember, we spoke of AIP, it's the CV, the resume of the card. It adds it to this, and it adds the current value of the application transaction counter. And it basically combines all of these to produce the desired cryptogram. Excuse me. So the card will take those 10 data elements that we discussed in the previous slide. Okay, and it will basically write it as a string, and it will then encrypt that string with the DK auth key, using a triple DES algorithm. I'm sure you guys remember we spoke of each card having a unique DK auth key, and we spoke of those three DES keys: DK auth, DK enc, and DK mac. So it uses the DK auth key here to generate this. As I've just said, the DK auth key is unique to the card, and it's securely stored on the card. Right? It's stored within a secure element on the card, and nothing has access to the secure element. These cards can never be retrieved. There's no programmatic call that can be made to ever retrieve these keys. They are stored on the card, and they are never accessible to any party other than the chip itself, the card itself. Right. So the example of what a cryptogram could look like is here. I mean, it doesn't mean anything if you look at it. It's just an encrypted string of data. Okay, so let's look at if we had a special tool and we were having a look at the conversation between the terminal and the card. This is what the first gen AC step would look like, right? It starts off with a terminal, sending an AE command, uh, or, it's a command generate application cryptogram request, okay, with a particular value indicating what it expects from the card. And then if you look down here, you'll see that, oh yeah, sorry, and remember those tags I spoke about that should be included to build the cryptogram. So here's a list of those tags that we discussed in the previous slide. Okay, you look at the ICC. So this is what the card responds would. Okay, so 927 with the length indicator, and then it says here's what I think we should be doing, right? And if you analyze the string of data, if you look at the data analysis, you'll see that tag 927 is the CID cryptogram information data, and the value of 80 that we see is an authorization request cryptogram. Okay, it's 82. It's a value of 80 there, so just tells me that the log is quite old, and obviously there was an error in the program, which I've only just picked up now. But it's not a train smash. For the purpose of this training, we can work with this, right? There's the application, transaction counter, etc., and this step was then successful. So let's have a look at it in a little bit more detail. So the top part, remember the terminal. This is where we're saying let's request a cryptogram, and in this case, we know that the terminal is asking for an 80, which is it's asking for an ARQC. Okay, the card weighs up the options and it makes a final decision in tag 927, and it comes back with the 82, which is fine. This also stands for an ARQC. Okay, right. So let's have a look in a bit more detail. So terminal says, it passes this to the card, and if you look at it, here's what it's passing through to the card. So 80 AE 800025. If you break that up, 80 AE is a generate AC command, and then byte 3, this is the actual request, right? And so byte 3 may have the following values. Okay, it could have, so if the terminal was requesting an AAC, a decline, this this value would be is 00 or 10, right? So 00 if during the transaction we had not yet asked for CDA, or this happened after CDA was processed on the terminal, if it's a 10. Okay, the terminal, if this value had been an AE 40 or 50, it means that the terminal was asking for an approval. 40 where we have not yet done CDA, and a 50, where CDA was processed already. And then we come down to the one that we're seeing here. So we're seeing the 80, and the 80 is ARQC CD not requested, and the 90 is ARQC. So 80 or 90 refers to a suggestion by the terminal for the card to generate an ARQC cryptogram for the transaction to go online. So all other values outside of these 6 for now are reserved for future use. Okay, so you shouldn't see anything beyond that. We now look at the terminal. We now look at the card response. So there's the ICC, and in response to the ATA80 that we saw in the previous slide, the card, does its card action analysis, and then it responds here in first gen AC with a 9F27 0180 and some data. Okay, and so let's analyze what this means, right? So 9F27, that's your cryptogram information data, and it looks like I fixed the slide here, so it's slightly different from the previous one. We have spotted the error, but in any case, the card has responded with an 80, which ties up with what the terminal asked for, and an 80 is an authorization request cryptogram. Okay, and then you'll see the application transaction counter, etc., etc., and it eventually comes back with it generates the actual cryptogram now, and here's the value, here's the actual cryptogram, indicating that the transaction should go online. Okay, and at the end of it, we know that the first gen AC phase of this transaction was successful. Right, so the card response was, let's focus on the 9F270180, this component here. Okay, so there's it there. We know 9F27 is the CID, the cryptogram information data tag. The length is 01, so it says it's 1 byte, so 2 characters. And then we have the actual value. Now, here's what you should note. When it comes to the card, so remember the terminal, we had only 6 possible outcomes, right? With the card, there could be more detail. So the important thing to remember is in this 1 byte value, right? So 1 byte says that there's 2 characters. Focus on the first character. If it starts with a 0, it means that the card has decided to decline the transaction. It's generating an AAC. If the first character starts with an 8, then we know that the card has opted to send the transaction online, and it's going to generate an ARQC cryptogram. And if the first character starts with a 4, it means that the card has decided to approve the transaction. Okay, the X's are variable, which could indicate different conditions, which we'll touch on briefly just now. Okay, so the CID values are presented as a 1 byte value, as I just said, where the first character explicitly indicates the outcome. Starts with a 0, it's a decline. Starts with an 8, it's an ARQC. Starts with a 4, it's an approval. The second character indicates if an advice must be sent by the terminal, as well as indicates specific reasons for a particular CID outcome. Okay. Now, what is an advice? So basically, issuers, banks, the banks that issue the cards may wish for the card to send an advice message back to the host in certain conditions, right? To advise the host system of certain conditions. This advice message is separate from either the authorization request or a clearing message. Okay, it's a separate message sent independently of either the auth request, auth response, or clearing message. As it stands right now, it could have changed in the last few months, but as far as I'm aware right now, advices are usually only associated with pin trial limit exceeded conditions. Okay. However, this could be expanded later in future to allow for advices for other conditions as well. Right. So, and okay, I know I'm speaking a lot, but let's just get let's just slow down a little bit and let's just look at exactly what I'm talking about. So, if you see a 9 of 2701 value, which is then followed by a 00, it means it's a straightforward, it's a decline. No advice needs to be generated back to the host system, and there's no real information given as to why you want to decline here. If it's a 01, similar, no advice required, but the reason now is that service is not allowed, or rather the condition we found during this transaction was that something about the transaction was not allowed, right? The service not allowed. If it is a 02, once again, no advice required here, but in the transaction, we know that the pin trial limit was exceeded. If it was a 0A, okay, it's similar to the 02, right, where it's indicating that the pin trial limit, and when we talk about pin trial limit, we're talking about the offline pin trial limit, right? It's the pin trial limit that's stored on the card. Okay, so this has been exceeded, but in this instance, we want an advice to be generated and sent up to the issuer host by the terminal. Okay. If it's a 03, once again, because it starts with a 0, it's a decline. No advice required. Remember, we said as it stands now, we currently expect only to send advices up for pin trial limits exceeded. The others are not currently supported, right? So in this one, once again, no advice required, and the reason for the decline is that issue authentication failed. And so what we're saying is we would never really see this in first gen AC, which is what we're discussing right now, but it would be present when we do the second gen AC, which we'll get to in a few videos time, right? So I think just to speed it up a little bit more, so using the same sort of principle, we can see that when it comes to TCs or approvals, they all start with 4, and the second character 0, 1, 2, 3 means different things. In this case, none of them require an advice to be sent. However, you'll see no information for 0, service not allowed for 1, pin trial limit exceeded for 2, and issue authentication failed for 3, similar to the above one. Should only be present in second gen AC and not in first gen AC. Okay, and then the same sort of principle applies here, right? You'll see we've got 1, 2, 3, 4, 5 options. 4 of them say that no advice should be sent up, and one of them says that an advice is required. As we know, it's only for a pin trial limit exceeded condition. Okay, look, so this isn't something you need to sort of learn off by heart. You make a note, write in your notes, and so when you are reading the logs, and you do see these things, I mean, it's easy enough to understand that if you see a 4, if you see if you see a 4, it's an approval. If you see a 0, it's a decline. But it'll help you just to identify possibly why the decline happened, because in the transaction a service was not allowed, and this allows you the opportunity to then go and interrogate more data to understand better which service it was specifically that was flagged as not being allowed for this transaction. Okay. Okay, so At this point, the transaction can either complete offline, AAC or TC, or it can be sent online. Now remember when we first started the video, we had the flow and we had sort of two-step tens showing there, and that's what we're talking about here. So if we complete it, if we generate an AAC or TC, it means we are completing the transaction offline and the transaction is now complete, right? Bob can take his socks and he can walk off. But if we decide to send the transaction online, then that's a sort of a different part, and there are additional steps related to the transaction going online. Should an ARQC be generated? Okay. So as I said, if it's an offline approval or decline, transaction is complete, and the cardholder will be asked to remove the card from the terminal. For the purpose of this training, because we want to actually see the full 14 steps of the transaction, let's assume that in this transaction, there was some condition present that there was an agreement between the terminal and the card that this transaction needed to go online, right? So the card made a decision and said, in first gen AC, I'm generating an ARQC. Okay, and I'm going to then tell the terminal, Mr. Terminal, please construct the ISO 8583 message and let's send this transaction online. We need further input, from the card's issuer host system before we can make a final decision later on in second gen AC. Okay, so that brings us to the end of the first gen AC phase of the transaction. Okay, in the next video, we are going to be talking a bit about the issuer decision. So yeah, and so that brings us to the end of this one. Thank you very much for spending this time with me, and I look forward to catching you guys in my next video. Take care, cheers, and bye-bye.